Welcome to finding inverse algebraically. Let's get started. Now remember that inverse is a function that's reflected over the y equals x line, which is my diagonal line. So if I had a point -5, +5, then my inverse point would be +5, -5. We switched our x and y's. We just switched these points together. And you can see on the graph that it is a reflection over this diagonal y equals x line. Now the steps to finding it algebraically. The first thing you want to do, sometimes your f of x is already y, but if it's not, change your f of x to y. Then, just like we did with these points, my x became my y and my y became x. I switched my x and y's to get my new point. So you switch your x and y. X becomes y and y becomes x. Number 3 is you're actually just going to solve for your y now. So let's do an example to see what that looks like. So first thing we wanted to do is change f of x to y, so we can work with it. Now our x becomes our y and our y becomes our x. We switch our x and y. So x equals log y minus 2. So see, my y became x, my x became y. Nothing else changed, just those two variables. Now we want to solve for y. Now this is where that changing forms comes in. First off, you want to remember that if there's no base here, there's no little number right there on a log, it's assumed to be 10. So this right here is a 10. Now the other thing is, remember the changing forms was log base a equals x, and it changed to base to the x equals a. So that's what we're doing here. We're changing from this form to the exponential form. So my base is my 10. And we're going a little bit backwards, but my 10 to the power of x equals y minus 2. So 10 to the power of x equals y minus 2. And then we just add the 2 to both sides. So my y equals 10 to the x plus 2. And then, of course, your y can go back to f of x with that -1 telling me that it's the inverse. Now remember, when we did this graphically, the inverse of a log was an exponential function. So you can see that when you did algebraically the inverse of log, you got an exponential function. So this is 10 to the x plus 2. So you try the log x plus 4 on your paper. Follow the steps that we did here. Make sure you change that log form to that exponential form. And then keep solving for y. Now here's the next example. Now we're going from exponential to log. It's going to be the same thing. We have a y instead of the f of x. Then we switch our x and y. So my y became x, my x became y. Then we just start solving. Subtract the 4 from both sides. So x minus 4 equals 10 to the y. And now I've got this exponential function that I can switch back into the logarithmic. So log base 10 of x minus 4, because I put this whole piece right there, equals y. And I'm done. I've got my inverse function is log base 10 x minus 4. So the inverse of an exponential function is a log function, which we've learned how to do graphically. So now you try 10 to the x minus 7 on your own, following these same steps. So let's do one more together. This is exponential. I've just got an extra step here, but we want to start off the same. Y equals 10 to the x plus 4 minus 5. This becomes an x. That becomes a y. I'm going to add 5 to both sides first. Then I want to change to my logarithmic form. Here's my exponential form. We're going to switch this to logarithmic form. So log base 10 of x plus 5 equals y plus 4. So what I meant was this is my extra step. Then I just have to subtract the 4 from both sides. And you just subtract it from the end like it's a k. So see, you have an h and a k, so that negative 4 came over to be the k. And if you notice, this h up here, your h is negative 4 and your k is negative 5. Well, down here, your h is negative 5, your k is negative 4. These are inverse graphs, inverse functions. So now you try the next one on your own. Here are the answers, just so you can check and make sure you did it right. First one, 10 to the x minus 4. This one, log 10 base 10 x plus 7. And this last one, 10 to the x minus 2 minus 3. Thanks for watching. See you soon.